Hello students, this video will be a teaching on what I call complex givens for stoichiometry problems. Often we encounter a problem like we see on the Stoichiometry Practice 2. It's page 10 of your student note packet, and questions 7, 8, and 9 present this category of complex givens. Sometimes we are not given masses or moles as starting givens. We might be given mass percentages. For example, we could be told that we're dealing with a mixture, that we're given a certain substance that is, let's say, 15% sodium chloride in the mixture. That just seems a little different than what we've been working with. And so that's going to fall into the category of what I just like to call a complex given. This is a bit more involved than what we've been working with. Here is the key. We want to ask ourselves, in a given, can that number and unit be expressed as a conversion factor? That will really be the key to these problems. So let's go ahead and just dig in to the first problem here, problem 7. And so if you want to take a moment to read that, and I think I need to move it this way so you can see. All right, so if you want to pause and read. We are asked to find the grams of air. Oh, that's a little different. Okay. Required to complete the combustion. We're burning of 93 grams of phosphorus to, so 93 grams of phosphorus to, it seems like we're making diphosphorus pentaoxide, assuming air to be 23% oxygen by mass. Okay. Oh gosh. Well, we always know that stoichiometry begins with a balanced equation. Okay, it says we're combusting. Well, we have phosphorus and we're making this. Oh, this must be kind of a stretch on what we call combustion. I mean, it looks like, what I need is oxygen. And I definitely know oxygen is diatomic. So that must be because I'm reacting this with oxygen while it's called combustion. And let's see, to balance this, I would need a 2, a 4, and a 5. Okay, let me write that just again so it's nice and clear. Plus a coefficient of 5. All right. So, okay, how many grams of air? Well, where on earth is air in? Oh, that must be the source of my oxygen. Okay, so I have 93 grams of phosphorus. Okay. And I know that I'm trying to make this, but the question is, how many grams of air, I guess will be needed to supply the oxygen? Well, what else am I given? A mass percent. Now, as we saw with percent yield, we can convert percentages to be literal expressions as ratios out of 100. To say that air is 23% oxygen by mass, that is saying for every 100 grams of air, there are 23 grams of oxygen, or I'll have 23 grams of oxygen per the 100 grams of air. Conversion factors. All right, so I have 2 givens. mass of phosphorus, and then this mass that oxygen is of air, but I've converted them into a conversion factor. Okay, so I have two givens. Let's dig in. I would encourage you to always start with your quote unquote simpler given. This is a mass. It is just 93 grams over 1, where your percent, you convert it into a conversion factor. That's a little more complicated. So let's start here and just see where that takes us. Okay, we want to find grams of air as our final answer. So we have to keep in mind that's what we want to relate to. Okay, so I'm going to start with my 93 grams of phosphorus. Okay, well, where do we go from there? Where do we usually go? To moles. And so we have 30.97 grams of phosphorus in every 1 mole. Why do that? Well, because that gets us to the mole ratio. So per my reaction, there's 4 moles of phosphorus for every 5 moles of oxygen. Okay, so what this has done is gotten me to moles of oxygen. I'm getting closer because now oxygen, well, that is what air is giving me. Okay, well, if I look at, how I've expanded these, they're in terms of grams of oxygen in grams of air. So let's try a next step, getting ourselves from mole of oxygen, and we know it's diatomic, so it's 32 grams. Okay, now this is grams of oxygen. So I'm going to use this setup because look, if I put the 23 grams of oxygen in the denominator and then 100 grams of air on top, that cancels grams of oxygen, and then I'll be left with grams of air, which is what I need for my answer. So look at that. Look at that. So I made a conversion factor out of a given percentage, and I made sense of what I was given in the problem to get my balanced chemical equation. I started with the simpler given, and I used the percentage as a conversion factor. And so when we do our math, now the 93 limits us to 2, and the 23% limits us to 2. And so the answer that we get for number 7 is 520 grams of air. Okay, so that is the first guiding complex given problem, number 7, in the Stoichiometry practice 2. The next video will lead us through number 8 and number 9.